Mercury, the closest planet to the Sun, orbits at an average distance of about 58 million kilometers. Although it's close to the Sun, its temperature is actually much lower than Venus. NASA's Messenger probe was the first spacecraft to successfully orbit Mercury. During its mission, Messenger took over 200,000 images of Mercury's surface. These photos revealed a surface covered with impact craters of all sizes. Notable features include large craters and the massive Caloris Basin, over 1,500 kilometers wide. Mountains surrounding the Caloris Basin reach nearly 2 kilometers high. Messenger completed its mission on April 30, 2015, eventually running out of fuel and making a controlled impact onto Mercury's surface. Just before crashing, it sent back some of its highest resolution surface photos as a final farewell. Many believe Mercury is the hottest planet, but actually the second planet, Venus, holds that title. Venus's atmosphere, mainly carbon dioxide, with clouds of sulfuric acid, creates a dense greenhouse effect. This traps the sun's heat, pushing surface temperatures up to around 470 degrees Celsius. The Soviet Union's Venera 13 probe sent back the first color images from the surface of Venus. Although designed to last only about 30 minutes, after landing on March 1, 1982, it operated for over 2 hours, demonstrating its robust design. In 1990, the US launched the Magellan probe, which used radar to map nearly the entire surface of Venus. Its data revealed a world shaped by intense volcanism, possible tectonic activity, strong winds, and vast lava channels, like Balta's Valles, stretching nearly 7,000 kilometers. After completing its mission, Magellan was also directed to plunge into Venus's atmosphere, ending its journey. Earth, the unique cradle of life in our solar system. It's the only planet known to harbor life. And while images of Earth are countless, high-definition views from modern satellites remain breathtaking. For example, instruments like those on NO satellites capture stunning full-disk images of North and South America from geostationary orbit. Sometimes the moon can even be seen in the background. On December 14, 2020, NOS-16 satellite filmed a total solar eclipse moving across South America, leaving a valuable visual record. And you might not know this, but in March 2011, a Russian satellite called Elektro captured incredibly detailed images of Earth. Some argue these images rivaled or even surpassed others available at the time. And as Japan's Hayabusa 2 probe headed towards asteroid Ryugu, it looked back and captured this postcard-like view of the Earth and Moon saying goodbye. Mars, the red planet, has captivated human attention for centuries. It's the fourth planet from the Sun, and its surface has been extensively surveyed by numerous probes. In 1979, NASA's Viking 1 orbiter captured magnificent views of Valles Marineris, the Grand Canyon of Mars. And the Viking 2 mission provided data on the northern plains and polar ice caps. In 2013, ESA's Mars Express orbiter captured high-definition images of Hades Chasma, part of the Valles Marineris system, which were even turned into animations. To date, several rovers have successfully landed on Mars to explore and send back images. NASA's Curiosity Rover took a famous set of selfies, a clear sign of our robotic presence on another planet. One of its most amazing feats was creating a 1.8 billion pixel panoramic mosaic from over 1,200 images, revealing the Martian landscape in incredible detail and vastness. Moving further out, Jupiter is the largest and one of the most visually striking planets in our solar system. The gas giant's most iconic feature is its great red spot. It's a colossal superstorm, raging for over 350 years, and large enough to swallow the entire Earth. On July 10, 2017, NASA's Juno probe flew just 9,000 kilometers above the Great Red Spot, capturing unprecedented close-up images. Compared to images from further away, these offer a much more detailed view, closer to true color. Juno has also provided the first detailed observations of Jupiter's polar regions. These polar regions, invisible from Earth, held surprises. Juno discovered complex storm systems like 8 cyclones, precisely arranged in a geometric pattern around the North Pole. These storms appear remarkably stable, seemingly locked deep within Jupiter's atmosphere. Using data gathered on November 13, 2018, scientists composed highly artistic and detailed images of Jupiter's swirling clouds. When considering the most beautiful sights in the solar system, Saturn often comes to mind. Its elegant planetary rings are perhaps the most familiar visual wonder beyond Earth. Many of the most exquisite images of Saturn come from the Cassini-Huygens probe. On October 21, 2002, while still about 285 million kilometers away, Cassini captured clear photos of the ringed planet. And on March 27, 2004, just before entering orbit, it returned stunning images in natural color. One of the most breathtaking views occurs when Saturn is backlit by the sun. This unique lighting angle reveals intricate details in the ring system never observable from Earth. Around that time, the Hubble Space Telescope also contributed, capturing images of Saturn's auroras. Later in its mission, in 2016, Cassini sent back images of Saturn's northern hemisphere, revealing a surprising feature: a giant, stable hexagonal storm structure at the pole, a phenomenon still not fully understood. It undoubtedly reveals the mysteries of atmospheric dynamics on other worlds. On September 15, 2017, Cassini made its final plunge into Saturn's atmosphere, burning up like a meteor, becoming part of the giant planet it studied for so long. Uranus is sometimes called the sideways planet. Its axis of rotation is tilted nearly parallel to its orbital plane, giving it a unique orientation as it orbits the Sun. In January 1986, Voyager 2 became the only spacecraft to fly closely past Uranus, capturing rare images using various color filters. Much later, on July 11 to 12, 2004, the Keck telescope composed infrared images showing Uranus's icy blue hue, its faint ring system, and bright spots corresponding to auroral activity. In November 2011, the Hubble Space Telescope also took images, showing the ice blue sphere potentially contrasted with reddish hues in its rings, depending on the filters used. Observations of auroras on Uranus continued, with sightings reported again around 2017, adding to the mystery of this distant ice giant. Further still lies Neptune, the outermost planet in our solar system. To date, Voyager 2 remains the only spacecraft to have made a close encounter with this 8th planet. During its 1989 flyby, it photographed huge storms raging in Neptune's atmosphere, including the famous Great Dark Spot. After completing its Neptune encounter, Voyager 2 headed towards interstellar space, looking back to photograph bright streaks of high-altitude clouds in the planet's atmosphere. The Hubble Space Telescope continues to monitor Neptune from afar, documenting changes in its atmosphere like the appearance and movement of dark spots, such as a large one observed in December 2020. Due to Neptune's vast distance, these Hubble images are among the clearest views we can currently get from the vicinity of Earth. Additionally, advanced ground-based telescopes like ESO's Very Large Telescope, using adaptive optics, have captured remarkably sharp images of Neptune. Whether Pluto should be classified as a planet is still a topic of debate among some. Regardless, the images returned are amazing. Some of the clearest pictures we have of this distant dwarf planet come from NASA's New Horizons probe. It captured its most detailed survey images during its historic flyby on July 14, 2015. By combining images taken through different filters like blue, red, and infrared, scientists created enhanced color views, approximating what Pluto might look like and highlighting different surface materials. New Horizons continued to take high-definition pictures as it flew past, also capturing images of Pluto's moons like Charon. Composite enhanced color images revealed stunning details, including vast plains of nitrogen ice and towering mountains made of water ice. Capturing detailed images of planets orbiting other stars, like Proxima Centauri b, is incredibly challenging due to the vast distances. With current technology, sending a spacecraft there would take thousands of years. But humanity has conceived an ambitious project called Breakthrough Starshot. The plan involves tiny, lightweight nanocraft attached to thin light sails, propelled by powerful ground-based lasers. These probes, accelerated to a fraction of the speed of light, could potentially reach Proxima Centauri in just 20 to 30 years. If realized, this plan could one day bring back the first close-up images from another star system. Thank you for watching. Don't forget to like, share, and subscribe for more space adventures.